Thanks for watching today. Today we're going to cover how Wireshark works. And so first let's go ahead and start a capture. We'll go up to capture interfaces. And I like to start it with interfaces because a lot of times people will have different interfaces and they're not sure which is the active one. But in this view you can actually see the packets flowing over the interface, so you can select the proper one. Now we're not going to select it here, we're going to select options. Okay, here's the options dialog box. And one thing I wanted to say is under display options at the bottom right, go ahead and check all of those, okay? Excuse me. Now normally you wouldn't do that because if you display the packets on the screen, it takes a lot of resources to do that, and that is of course taking resources away from your computer's ability to capture packets. So by displaying them, you're actually increasing the risk that you may drop some packets. So normally you just write the packets to a file and go back and analyze them. However, since we're learning, we're going to set this up with these display options here, and you can go ahead and click all of them. The name resolution ones, are kind of optional, but the display options, you want update list of packets in real time, automatically scroll during live capture. You want those too, so you can see the packets coming in. We're going to select capture on all interfaces, and there's in the bottom right there, which is off the screen that you can see, there's a start button, so if I select that, we should be going. Okay, here we go. Now what I'm going to do to make sure we have some traffic is I'm going to actually run a scan of my network. So I'm going to go under the host. This is Armitage, which is a graphical user interface for Metasploit. So I'm going to put my network address in here. With the CEDAR notation -24, which indicates 24-bit submask. So that's why I put the 24 there. So, and then we should see Nmap tab come up and start scanning, which we do. Very good. So we're going to minimize this and go back to our Wireshark. Okay, as we see here, the packets are coming in. And just looking at the Wireshark interface gives you some information. At the bottom left, you can see live capture in progress on 4 interfaces. And then it gives you a little caret, and it gives you the file of where these are going to be saved to when you exit. Now you can save that file. This isn't necessarily the default the default directory that this is saved in, and the default name are not necessarily the best. But you can change that, and you can also change it when, if I was to stop it and close it, it says, do you want to save? You can save it. You can choose another directory then to save it in, and change the file name then as well. So we have the file name. Then we have a space. If you look closely, you can see it. And then you see this incrementing number. It's 1666, 1696, 1706. That is actually the size of the file. So it gives you a live update on the size of the file. Now if we change the stats panel around a little bit, it's so we can see the second or middle panel. That's given us the packets that we're capturing. And this number in here should match, if we go up to the top window, the packet number in that first column should match the packets. And again, this number has actually nothing to do with the packet. It's just Wireshark's way of incrementing them. So it has absolutely nothing to do with the actual packet, but it's Wireshark's way of keeping track. The third stats panel is something that we're not going to talk about today, but it's profiles, and you can set up different profiles depending on what you're doing. and your different profiles can have different menu selections, and it can have different coloring rules. As you see, the packets coming in, they have different colors, so you can change that based on what you're actually doing with Wireshark, and that's called profiles. So as we're watching this, we can see there are 3 horizontal windows. The top window has kind of the overall packet information. The second window is giving us information about whatever packet is selected in the first window, which would be probably the first packet when we started today. And the third window is the actual contents of the subdivision of the packet we're looking at. So in that third window, if you look at it closely, you'll see there's 3 columns. The first one is the memory space in the packet. The second one is the hex contents, and the third one is the ASCII contents. So it looks like it's slowing down here. We could go back and see if our scan is done, and it is done. So we can stop our capture. You'll note that I did a scan on my local network, and so there's a lot of Linux. The penguins, of course, represent the Linux boxes. Now, is that because I have I live in a data center or something like that? I have a bunch of big servers? No, that's because a lot of devices are actually Linux in a home network. And devices I have that would show up as Linux are Android phones, iPads, digital video recorders. I have a network attached storage that runs Linux. Why would why would Apple products show up as Linux? Because Apple products are really a port over BSD Unix. So that's why. So let's go back here and stop our capture. So this first window, again, a high-level overview of the packets. And I like to explain an IP packet as like a piece of mail. When you look at a piece of mail, you have in the upper left the return address. And then in the middle of the envelope, you have where it's going. So you have the source and the destination. And you have the same thing on IP packets. You have the source and you have the destination. Except instead of being like a street address, it is an IP address. That's the difference. So in this top column, you have the number of the packet, the time, which is useful to see if you have delays or something like that going on. You have the source, the destination. This other column is very important. It's a protocol column, and that's a column that you'll probably be using quite a bit. Now this is a Windows column display, I believe it's called. So if you click on any of these columns, you'll sort by that column. As it is by default, it's sorted by the packet number. So the first packet through whatever your last packet is. So it's sorted by that column. But you can sort on protocol just by clicking on that, and you see it has a little arrow there. Then if you want to go back to sorting by number of packet, you just click on that. So, and you can see here as we click on this, these other windows below change. Now that's because when we highlight something in the top window, then it shows us the subdivisions in the second one, and we highlight the subdivisions, it shows us the contents down below there. So if I click on a different subdivision, it's going to change it a little bit. Now I said that the third column was ASCII, and that's actually English readable encryption. You can see if you look in there, I bet that has something to do with one of my TiVos, because it has TiVo in there. So hex, of course, is each character represents one of 16 possible values, so it goes 1 through 9, and then A, B, C, D, E, and F for each of the characters in here. So you should see all the numbers and the letters A through F. And this is the same thing in this third column, except instead of being in hex, it's in ASCII, which is an encoding that can represent the English language. So we're going to look at a way. Now we have, as you can see, we have 14,000 packets. So I have these 14,000 packets. How do I see if there's something in there that shouldn't be in there? Well, it would be tough, but what we're going to do is we're going to get rid of the packets that should be in there. And when we do that, we will be left with the packets that shouldn't be in there, right? Does that make sense? Now, there's a couple of ways that Wireshark allows you to filter. It has capture filters, and that eliminates the packet before it actually gets captured. So let's say I'm on a really big network and I want to just look at ARP traffic. I could use a capture filter. That way I would only see ARPs. I wouldn't be in much danger of dropping anything because it will eliminate most of the traffic. But the problem with that is I can't later go back and look at other protocols or things that were filtered by the capture filter. What we're going to use instead of capture filters is a display filter. Now, a display filter just changes what is displayed. All the traffic is there in the original file. You can clear the display filter out and go and see it, but it only allows what you choose to allow to be displayed. Okay, so let's think of some traffic that we would expect to be in here that we wouldn't really be interested in. Okay, so one type of traffic would be web traffic, web browser traffic, because this computer's hooked up to the internet, so we'd expect to see some web traffic. So we're putting a display filter in, not TCP port 80. So that means don't display stuff where the TCP port is 80. Now it doesn't really do anything. You have to actually hit apply. And then there's not going to be a lot of packets, but there might be some. Let's see. Yeah, there was some. Okay. Then we could do and not let's see, we'll do TCP port. This is just for informational purposes. (111). What's 111? I can type. 111 is actually the kind of the Unix equivalent of 137 through 139. Linux uses that for like file sharing and remote procedure calls. So this is called RPC bind or Portmapper. And this is indicative of a Linux network. Now I should have some. I'm not transferring any big files on any of my Linux devices, so I may not see too many, but I might have some because there are a lot of Linux devices. So this is one of the ports that when you use Nmap to do a fingerprint of an operating system, if it sees port 111, that's a good indication that it might be a Linux box when you're scanning it. So let's see if there's any of these. Let's hit apply. There's not going to be too many, but let's see. Yeah, just a couple. Okay. And again, if I was transferring big files or something like that, I would expect there to be more, but I'm not. This next one again is an informational filter I'm putting in here, as it's a filter you would commonly use, although I'm not expecting to see any of it. Okay, what's port 389? Well, that is the port used for LDAP, and so that is the directory services port. And directory services, what that does is it allows your computers to just query this one uh, directory service computer to get the resolution of services on the network. And if you think about it, if I wanted, we'll say a pizza delivery service, I could pick up my phone and go 488-1111 and then call you a pizza place. No, okay, 488-1112. Now, if I went about it that way, that's kind of like a broadcast packet, right? I'm just hitting everything, right? A better way to do it would be if I went up and got a phone book and pulled it down. Now, I'm kind of like at the very edge of the town I live, Colorado Springs. But, so if I pull down the 5-inch thick Colorado Springs phone book and look up restaurants, I still would have to go through it, and most of them are going to be a long ways away, not delivered here. Have to look for pizza places. If I went over to my bookcase and pulled down the 1-inch thick Monument phone book, I would be looking under restaurants. I'd have a lot less filtering to do. Looking under pizza, I would have almost all of them would be good, so I just have to decide which one. And then if I remember a specific pizza place, Joe's Pizza on the corner, I can go to the white pages and boom, I don't have to make any decision at all, because there would be the phone number. So how you go about looking things up can make a great deal of difference of how long it takes and how much effort you have to put in. So that's why directory services on a network, and again, we're not talking about pizza delivery, we're talking about network service, but that's why they're so effective on a network, and that's why most big networks you'll see, enterprise networks, will have directory services. You can also filter for source port, like this. This is source port. And this was that BIOS naming service that we talked about earlier. So the source port is 137. That's going to get some of our NetBIOS naming service out. So if we apply that, let's keep an eye on how many are displayed here. Okay, see it filtered a few out. Now I don't expect anyone, don't be thinking, oh, I got to write that down and memorize it or something like that. Nobody watching this one time is going to remember all these ports, okay? So I don't want you to concentrate on that. Excuse me. I want you to concentrate on troubleshooting how Wireshark's used and how by eliminating the logic of eliminating the expected traffic gives you the unexpected traffic. Eliminating the traffic that should be there gives you the traffic that shouldn't be there. I want you to concentrate on that. Don't concentrate on all the specifics, and don't think you need to, don't feel bad if you don't know all this, because nobody could watch this one time and know it all. So, and not. So we could also do UDP destination port. And that should give us some more, because they use NetBIOS naming service uses both. So let's see if that gives us some. Should be some, not a whole bunch. Oh wait, let's see. It gives you a nice error message there. I misspelled UDP, so it should be UDP. Yeah, there we go. And notice how if it turns red, that means like stop, you're not, and green means go ahead. Might have given us a few. I couldn't really see. Not a whole bunch. So we got some of it, but we could go through. Now there are going to be times when you just want the source or destination port, depending on the traffic. And what would those times be? Well, we're not going to talk about that today, but I'm just making you aware of how you can slice and dice your results. Uh, and not net BIOS naming servers. Now, why didn't we just do that at first? Well, because I wanted to show you how you can do TCP, UDP, source port, destination port. And there will be times when that comes in handy. And as you get to using Wireshark and things, you'll run into those times. Okay. Because and again, we expect to see net BIOS naming service on this. This network has Windows hosts on it. We are an IP version 4 network, so we would expect to see ARP on here. Now, if we were completely an IP version 6, we might not see that, but this is an IP version 4. Okay, so that gave us a couple thousand packets were eliminated with that one. Okay. What is browser protocol? Do we have any of that? Well, we could actually, let's try that old filter trick that I showed you earlier. Yeah, we do have browser. What is browser? Browser is on a Windows network. When you hit network neighborhood, and it shows you the devices and resources on the local network. Now you can close that and go back to it, and it'll still be populated. And Windows uses browser for that type of functionality. Okay. Another one, if you're running both, if you're running both IP version 4 and 6, you'll have this next one. I don't think I'll have it on this network. Port 5355. And that is local link multicast name resolution. And it allows conversion of and address resolution of IP4 packets to 6 and vice versa. So again, don't worry about, I mean, if you do this a lot, then fine, you know, you might be able to remember one or two of these that you didn't know, or you may know a lot more than what we're doing too. But if you don't know this, don't, whoops, there will be no test after this, so I'm just showing you some stuff. This is SSDP, which is Simple Service Discovery Protocol, and it works in conjunction with Universal Plug and Play. So I have some like TiVo and other game boxes on this network. I kind of doubt if we'll see too many of these. Let's see. Yeah, we saw a few, surprisingly. This is a TCP network. Okay, so that got rid of some. Okay, we went from 14,000 packets to just over 200. And we did that by eliminating traffic that we would expect to be on here. Let's see what we got left. ICMP, we would expect that. We could get rid of that. Okay, now why is that showing up as red? Well, even though I've never seen ICMP ever in lowercase, for some reason when you're doing Wireshark, it has to be in lowercase. So, and this is a port of a Linux or Unix program, and Unix programs don't differentiate between uppercase and lowercase. So we can get rid of the ICMP. Okay, so now we have that got rid of 100 packets. So now we just have 100 packets. Now what do we got on here? Spanning tree, as you may be aware, is a router protocol. Now, is that normal to see a router protocol? Well, it would be if you were between two routers, but out here on a client like I am, that is not normal. So that indicates and we can tell it's coming from my access point and switch. So what I would need to do is go in there and troubleshoot it. Now what I suspect this is because I put some, as you recall, I'm capturing on all my interfaces. So I have my wireless capture going too. And my daughter had a party this weekend. She had friends over and they needed internet. So I just gave them an open internet connection, walled off from my normal internet connection and my normal network, of course. But I opened up a network that was open so they wouldn't have to give them a username and password. And I haven't turned it off yet. So I suspect if I wanted to troubleshoot this, what I would do is I would go in and turn this off. And then run it again. So, do I have anything else? Let's see. Okay, that's it. Now, I eliminated STP because I wanted to see if I had anything else, but really, we don't expect to have that on there, so we wouldn't really want to save that. If that still showed up, that would indicate a misconfiguration that still needed to be checked in there. But the rest of this was all expected traffic, and this we could save. Now there's a couple of ways we could do it. We could hit save here, and it will give us another button like this one. This, I saved it, it looks like July 3rd. If I hit save now, it would give me another button, and that would be this filter. That would be a really quick way of getting to the unexpected traffic, wouldn't it? Because you're eliminating all the expected traffic. So I could also copy and paste this out into a file, and then when I, next time I wanted to assess this network, I could just paste it in there. Again, that would get rid of all the expected traffic, and we could see if anything has changed or if there's unexpected traffic in there that shouldn't be. So, usually, you'll once you get rid of the expected traffic, then you can kind of drill in here and use the functionality to go through these fields and help identify what this might be. Now, in this case, since it's already telling me what the source is, and I already have a pretty good idea, there probably wouldn't be as much to be gained. But if you didn't know what this was, you could go digging through these packets and look for things that might help you identify them. Okay, so we've eliminated the expected traffic, so we're left with the unexpected traffic, and we've actually created a filter that we can save and reuse at a later date and check to make sure our network doesn't have other traffic that is questionable or needs to be checked into. Okay, thanks for watching this, and again, don't feel bad if you don't learn this all. If you stay with my my videos, this will be explained. I'll go into this later, and this will start making more and more sense to you. Today we just wanted to show you kind of some of the things you can do, some of the troubleshooting you might go through, and some of the logic that you might use doing a network assessment with Wireshark. Thank you.